Hi, my name is Ilan Lobel, and I'm a professor of operations management at Stern. I'm here to teach you a little bit about simulation. What is simulation? Simulation is a powerful technique that can be used to analyze systems that are too complicated to solve analytically. Before I show you a little bit about how simulation works in operations, I want to tell you a little bit about the history of simulation. Simulation was first developed in the 1940s to solve a problem in mathematics, which is pretty simple, which is how do you calculate the area under a function? If the function is simple, you can solve this problem analytically. If the function is complicated, you can't. So what can you do? Two scientists working in the Manhattan Project at the time came up with a brilliant idea, which was the following. You can throw random darts at the function. Once you throw the darts in, you can count the number of darts that came in under the function versus the darts that came in above the function. And the fraction that came in under the function will give you an estimate of what is the area of the function. The more darts you throw in, the better your answer. If you only throw in a few darts, you'll get a very poor estimate of what's the area under the function. But if you throw in many darts, you get a really good estimate. The same technique can be used for solving operations problems, except that instead of random darts, we're going to generate random customers using Excel. Let me give you an example of an operations problem that's too complicated to be solved analytically, but we can solve via simulation. Suppose the TSA hired you to analyze the expected waiting time of a passenger in one of its airport security checkpoints. Your first thought is, easy, I know how to do that. I can analyze that using the techniques I learned in my operations course. However, when you get to the TSA checkpoint, you realize that what you're facing there is not a straight up queue like you learned to analyze before, but you really have 3 queues in a row. What do I mean by that? I mean that you first come in as a passenger and you have your ID checked, and that's the first line you go through. Then you put in your bags through the X-ray machine, and to do that you go through a second line. Finally, you have to go through a metal detector, and that's a third line. So to analyze that, you really need to analyze the sequence of queues one after the other. How do you analyze a system like that? You can't use the formula you learned before because it's not a single queue, it's really a sequence of queues. So what you can do is simulate it by creating random customers arriving over time and being serviced over time and measuring how long it's taking them to get through the system. So how do you do this? You create random inter-arrival times, which are the times between 2 customers arriving in the system, and random service times, which is the time it takes to service somebody at one of these stations. Simulation is useful in queuing, but it's also used in a lot of other areas as well. You can use it for supply chain planning, you can use it for inventory management. It's also heavily used in finance. For example, the way people typically price financial options in Wall Street is via simulation. To run a complicated simulation, we recommend that you use a specialized software or some sort of add-in for Excel, such as Crystal Ball or At Risk. Here we're just going to cover the basics, and I'm going to show you how to do it using nothing but Excel.